What if the answer to humanity's most profound question, are we alone in the universe, is closer than we ever imagined? Picture a cosmos teeming with hidden worlds, ancient oceans beneath icy crusts, and mysterious signals traveling light years to reach us. In the past few decades, bold explorations and groundbreaking technologies have unlocked secrets of the universe once thought unattainable. From the detection of alien biosignatures in distant atmospheres to tantalizing traces of microbial life hidden in Martian rocks, each discovery nudges us closer to a revelation that could change everything we know about existence. Today, we're diving into 30 of the most astonishing cosmic findings, discoveries that could finally prove life exists beyond our planet. So, buckle up, because what we're about to uncover might just reshape your understanding of life and the universe forever. Now turning to our first groundbreaking discovery, let's explore the microbial signatures found in Mars rocks. Thanks to the Perseverance Rover, scientists have identified intriguing patterns embedded in ancient Martian rocks, patterns that closely resemble formations created by microbial life here on Earth. These fascinating structures were uncovered in Jezero Crater, a region believed to have once hosted a lake billions of years ago. What makes this discovery so compelling is the use of advanced spectroscopy tools and meticulous sample analysis, which revealed chemical compositions consistent with organic compounds. While these patterns are not definitive proof of life, they provide one of the strongest hints yet that Mars may have harbored microbial organisms in its ancient past. This finding not only reshapes our understanding of the red planet's history, but also guides where and how we search for life in our solar system. Could these rocks hold the key to proving that life once existed on another world? Moving forward, let's look at the discoveries beneath the icy surface of Saturn's moon Enceladus, a place where the potential for life is equally captivating. Moving forward, let us journey to Saturn's moon Enceladus, a tiny celestial body with an immense potential to harbor life. Beneath its thick icy crust lies a vast subsurface ocean, a discovery that has stunned scientists and ignited hope in the search for extraterrestrial life. This revelation came from the Cassini spacecraft, which detected geyser-like water vapor plumes erupting from the moon's southern polar region. These plumes are not just ordinary water. They are rich in organic compounds and contain salts, hydrogen, and other ingredients that are essential for life as we know it. What makes this discovery even more exciting is the presence of molecular hydrogen, a potential energy source that could fuel microbial life in the dark depths of the ocean. The warm, salty environment beneath Enceladus' surface mirrors conditions found in Earth's hydrothermal vents, where life thrives in the absence of sunlight. This tiny moon has become a key focus for astrobiologists, offering an environment that seems almost tailor-made for supporting life. In fact, upcoming missions are being designed to study these plumes more closely, aiming to unlock the mysteries of Enceladus' hidden ocean. Could this icy world be home to alien life waiting to be discovered? Let us now shift our gaze to Venus, where an unexpected find in its atmosphere has provoked one of the most intriguing debates in planetary science. Now turning to Venus, a planet long thought to be too hostile for life, we encounter a discovery that has reignited the conversation about its potential habitability. Astronomers have detected phosphine gas in the planet's upper atmosphere, a substance that is both intriguing and puzzling. On Earth, phosphine is primarily produced by biological processes, often as a byproduct of microbial activity in environments devoid of oxygen. The detection of this gas in Venus' atmosphere has left scientists both excited and perplexed, as it challenges our understanding of how life might exist in such extreme conditions. Venus, with its scorching surface temperatures and crushing atmospheric pressures, seems like an unlikely host for life. However, the upper layers of its atmosphere present a different scenario. Temperatures and pressures there are more moderate, potentially creating a niche environment where microbial life could survive. This groundbreaking discovery has sparked intense debate in the scientific community. Some researchers propose that the phosphine could be a signature of life in Venus' atmospheric clouds, while others suggest it might be the result of unknown chemical or geological processes unique to the planet. Ongoing studies aim to replicate these findings and explore alternative explanations, pushing the boundaries of our knowledge about life in extreme environments. Could the dense cloud layers of Venus harbor resilient microorganisms defying the odds? The answers remain elusive, but this discovery has undeniably opened new avenues in our search for extraterrestrial life. Moving forward, let us journey to another of Saturn's moons, Titan, where an entirely different set of conditions fuels speculation about exotic forms of life. Moving forward, we arrive at Titan, Saturn's largest moon, and a world that seems almost otherworldly. Titan's thick, orange-tinged atmosphere is rich in organic molecules, the very building blocks of life as we know it. These molecules, including methane and ethane, form a haze that blankets the entire moon, creating a chemical environment unlike anything found on Earth. What makes Titan even more fascinating are its surface features: vast lakes and rivers composed not of water, but of liquid methane and ethane. These hydrocarbon lakes could potentially serve as solvents for life forms that operate completely differently from those on Earth. Imagine organisms thriving in an environment where methane takes the place of water in cellular processes. It is a concept that stretches our understanding of what conditions might be considered habitable. Adding to the intrigue, Titan has a weather cycle reminiscent of Earth's, but instead of water, it is methane that evaporates, forms clouds, and falls as rain. This dynamic climate system, combined with the presence of complex organic chemistry, makes Titan a compelling target in the search for exotic life forms. The Cassini spacecraft and its Huygens probe have provided invaluable data about Titan's surface and atmosphere, unveiling a landscape that is both alien and surprisingly familiar. Future missions, such as the Dragonfly rotorcraft, aim to explore Titan's surface and probe its mysterious chemistry further. Could Titan's methane lakes harbor life forms that redefine our understanding of biology? As we continue to push the boundaries of exploration, Titan remains a key player in the cosmic search for life, holding secrets that may challenge everything we think we know. Moving forward, we set our sights on Ganymede, the largest moon in our solar system and one of Jupiter's many fascinating satellites. Beneath its icy crust lies a massive saltwater ocean, a discovery that has redefined our understanding of this enigmatic moon. Scientists estimate that Ganymede's hidden ocean could contain more water than all the oceans on Earth combined. This vast subsurface ocean exists underneath a thick layer of ice, kept in a liquid state by the immense tidal forces exerted by Jupiter's gravitational pull. The potential for life within this ocean hinges on a critical factor: the interaction between the salty water and the rocky seafloor, which could provide the chemical energy necessary to support microbial ecosystems. Similar processes occur in hydrothermal vents on Earth's ocean floors, where life thrives in complete darkness. Ganymede also boasts a magnetic field, a rarity among moons, which might shield its subsurface ocean from harmful cosmic radiation, further increasing its potential habitability. Adding to its intrigue, Ganymede's surface is a complex landscape of ridges, grooves, and icy plains, hinting at a dynamic geological history. To unlock the secrets of this watery world, the upcoming Jupiter Icy Moons Explorer mission, or JUICE, is set to delve into Ganymede's mysteries. Scheduled to arrive in the late 2030s, JUICE aims to study the moon's surface, magnetic field, and subsurface ocean in unprecedented detail. Could Ganymede's hidden ocean be a cradle for life, cloaked beneath miles of ice? These questions make Ganymede a thrilling target in our quest to find life beyond Earth, offering the tantalizing promise of discoveries that could forever change our understanding of the universe. Now turning to alien biosignatures on exoplanets, we enter a realm where science fiction inches closer to scientific reality. The search for life beyond our solar system has been invigorated by the discovery of biosignatures, key chemical markers such as oxygen, methane, and water vapor detected in the atmospheres of exoplanets within the habitable zones of their stars. These habitable zones, often referred to as the Goldilocks zones, are regions where conditions might be just right for liquid water to exist, a fundamental ingredient for life as we know it. Among these incredible finds is the exoplanet K2-18b, orbiting a red dwarf star approximately 124 light-years away. K2-18b has captured the attention of scientists due to its atmospheric composition, which includes water vapor, a rare and exciting discovery for a planet in its star's habitable zone. But that is not all. Further analysis suggests the presence of other gases, such as methane and carbon dioxide, hinting at the possibility of biological processes at work. While these chemical signatures are not definitive proof of life, they present tantalizing clues that demand deeper investigation. Advances in spectroscopic technology have been pivotal in these discoveries, enabling researchers to analyze the light filtering through exoplanetary atmospheres and identify their chemical components from vast distances. The detection of biosignatures has opened an entirely new chapter in the search for extraterrestrial life, steering scientists toward specific targets for future exploration. Missions like the James Webb Space Telescope are now stepping up to investigate these promising worlds, offering unprecedented insights into their atmospheric compositions. Could K2-18b or similar exoplanets harbor microbial ecosystems or even more complex organisms? While the answer remains elusive, these discoveries push us ever closer to understanding our place in the cosmos, raising the thrilling possibility that Earth may not be the only cradle of life in the universe. Moving forward, let's focus on Proxima Centauri b, an Earth-sized exoplanet that has captured the imagination of scientists and stargazers alike. Located just over 4 light-years away, Proxima Centauri b orbits within the habitable zone of Proxima Centauri, the closest star to our solar system. This habitable zone suggests that the planet might have the right conditions for liquid water to exist, which is a key ingredient for life as we understand it. What makes Proxima Centauri be particularly intriguing is its size, which closely resembles that of Earth, sparking speculation about its potential to support life. However, this promising world also faces significant challenges. Being in such close proximity to its parent star, Proxima Centauri b is exposed to intense stellar flares and radiation, which could strip away its atmosphere over time and make the surface environment hostile to life. These flares release high-energy particles that pose a serious threat to habitability, demanding that researchers consider whether life could exist underground or in protected regions. Despite these challenges, Proxima Centauri b remains one of the most exciting nearby targets for exploration. With advancements in telescope technology, scientists hope to analyze its atmosphere for chemical signatures such as oxygen or methane, which could indicate biological activity. Additionally, upcoming missions and projects focused on interstellar exploration may one day allow us to study this enigmatic world up close. The discovery of Proxima Centauri b has not only expanded our understanding of potentially habitable exoplanets, but has also reignited discussions about humanity's ability to reach and study these distant neighbors. As we continue to explore Proxima Centauri b's potential habitability, we are reminded of the vast possibilities awaiting us just beyond our cosmic doorstep. Now turning to Kepler 452b, often referred to as Earth's older, larger cousin, this remarkable exoplanet resides in the habitable zone of a star similar to our own Sun. Located approximately 1,400 light-years away in the constellation Cygnus, Kepler 452b has drawn significant attention due to its striking similarities to Earth. With a diameter about 60% larger than our planet, it falls into the category of a super-Earth, a class of exoplanets that are larger than Earth but smaller than gas giants like Neptune. Its orbit around its host star, which is nearly identical in temperature and size to the Sun, lasts 385 days, reinforcing its Earth-like qualities. What truly makes Kepler 452b intriguing is its position in the habitable zone, where temperatures could allow for the presence of liquid water on its surface. Scientists speculate that if this exoplanet has a rocky composition just like Earth, it could also potentially have volcanic activity, which might play a role in sustaining an atmosphere conducive to life. However, Kepler 452b's advanced age of roughly 6 billion years, compared to Earth's 4.5 billion years, adds an extra layer of fascination. This older age suggests the possibility of a more evolved environment, providing a longer window for life to potentially develop and thrive. At the same time, its larger size means that gravity on Kepler 452b would be stronger than what we experience on Earth, which could influence the planet's geological and atmospheric conditions in ways we do not yet fully understand. Current technology does not allow for a detailed study of Kepler 452b's atmosphere, but ongoing advancements in telescopes and observational techniques bring hope that this distant world's secrets may one day be revealed. Kepler 452b serves as a compelling reminder of the diversity of planets scattered throughout the cosmos, and how much remains to be discovered as we pursue the age-old question of whether we are alone in the universe. Now turning to Europa, one of Jupiter's most intriguing moons, recent discoveries of water plumes erupting through its icy crust have captured the attention of scientists around the globe. These towering plumes, which eject water vapor into space, provide compelling evidence of a vast subsurface ocean hidden beneath Europa's frozen surface. This ocean, potentially containing more water than all of Earth's oceans combined, lies beneath a thick shell of ice, and the plumes offer a unique opportunity to study it without needing to drill through miles of solid ice. Scientists believe that the plumes may carry material from the ocean below, including organic compounds or other chemical clues that could hint at the potential for life. Europa's environment, with its combination of liquid water, essential chemical ingredients, and a possible energy source from tidal heating generated by gravitational forces from Jupiter, makes it one of the most promising places in our solar system to search for extraterrestrial life. The discovery of these plumes has led to the development of ambitious missions like Europa Clipper, set to launch soon, which will closely study the Moon's ice shell, its subsurface ocean, and the plumes themselves. This spacecraft will carry advanced instruments capable of analyzing the chemical makeup of the material ejected by the plumes, potentially unraveling whether Europa's ocean harbors conditions suitable for life. With every discovery, Europa continues to tantalize us with its mysteries, reminding us how much there is to learn about the hidden potential for life within our own solar system. As we set our sights on these icy sprays, we edge ever closer to uncovering one of the greatest cosmic secrets. Moving forward, let us look at the fascinating world of red dwarf stars, the most abundant type of stars in our universe. These small, cool stars might not shine as brightly as our Sun, but they are proving to be hotspots for discovering habitable zone planets. Among the most intriguing finds is the TRAPPIST-1 system, located about 400 light-years away from Earth. This system consists of 7 Earth-sized exoplanets, 3 of which fall perfectly within the star's habitable zone, where conditions could allow for liquid water to exist on their surfaces. The sheer proximity of these planets to their host star means they likely experience tidal locking, where one side of the planet always faces the star, creating a stark contrast between a hot day side and a cold night side. Despite these extremes, the potential for life exists, particularly in the regions along the terminator line, where temperatures might be just right. Red dwarfs like TRAPPIST-1 are long-lived, burning their fuel at a much slower rate than larger stars, which provides a stable environment for billions of years, a timescale favorable for the evolution of life. However, these stars are also known for their intense stellar flares, which could strip away an exoplanet's atmosphere or expose its surface to harmful radiation. To address these challenges, researchers have focused on models that explore how magnetic fields or thick atmospheres might shield these planets, allowing life to persist even in harsh conditions. The tantalizing discovery of compact systems like TRAPPIST-1 has expanded our understanding of where life might exist, proving that red dwarf stars, once overlooked in the search for habitable worlds, could hold some of the most promising candidates yet. As we continue to study these red dots scattered across the cosmos, they remind us that life may not need a sun-like star to thrive. It might just require a stable home, the right ingredients and time. Now turning to the mysteries of interstellar space, let us uncover the discovery of complex organic molecules like amino acids within comets and vast interstellar clouds. These molecules, often referred to as the building blocks of life, are vital for the formation of proteins, which are essential to all known life forms on Earth. Their presence in the cold, dark regions of space suggests that the universe itself might hold a natural recipe for life, ready to distribute it to planets with favorable conditions. One fascinating example is the discovery of glycine, the simplest amino acid, in the coma of comet Wild-2, a revelation made possible by the Stardust mission. Similarly, interstellar clouds such as Sagittarius B2, located near the center of our galaxy, have also yielded traces of these organic compounds through the use of advanced radio telescopes. These findings hint at a remarkable possibility that the chemical precursors of life are not restricted to Earth or even our solar system, but are widespread across the cosmos. Scientists theorize that during the chaotic early stages of planetary formation, comets and asteroids containing these molecules could have bombarded young planets, delivering the necessary ingredients to kickstart life. This idea, known as panspermia, suggests that life on Earth itself may have been seeded by such interstellar materials billions of years ago. While this theory remains speculative, the growing evidence of organic molecules in space supports the notion that the universe is chemically primed for life. These discoveries not only deepen our understanding of how life might originate, but also expand the scope of where we should search for it. As we continue to study the rich chemistry of comets, meteors, and interstellar clouds, we are reminded that life's story may have begun long before the Earth formed, written in the stars themselves. Moving forward, let us turn our attention to the intriguing signs of life on early Mars, a planet that once held conditions strikingly similar to those on Earth. Billions of years ago, Mars is believed to have had a thick atmosphere capable of trapping heat, allowing liquid water to exist on its surface. Evidence collected by rovers like Curiosity paints a vivid picture of a planet that was once teeming with rivers, lakes, and even vast deltas. These ancient water-carved landscapes can still be seen today in features like the Gale crater, where Curiosity uncovered sedimentary rocks that could only have formed in the presence of water. Adding to this compelling story, the rover also discovered minerals such as clay and sulfate, which are known to form in liquid water and could potentially preserve biosignatures of ancient microbial life. One of the most fascinating findings came with the detection of methane on Mars. While methane can be produced by geological processes, on Earth a significant portion of it is generated by living organisms, sparking debate about its origins on the red planet. The discovery of organic molecules in Martian soil further fuels the possibility that life may have existed during Mars' wetter and warmer past. Taken together, these discoveries suggest that Mars was not always the dry, barren world we know today, but may have once been a cradle for life, holding the key to understanding how life could emerge and thrive beyond Earth. This evidence challenges us to reevaluate what we know about the potential for life on other planets, keeping Mars at the forefront of our cosmic quest for answers. With the next phase of the journey in sight, let us explore the captivating concept of Earth-like worlds located in the habitable Goldilocks zone. This term refers to the region around a star where conditions are neither too hot nor too cold, allowing liquid water to exist, a key ingredient for life as we know it. The growing list of planets discovered in this zone has fueled excitement about the possibility of finding extraterrestrial life. Among these remarkable worlds is LHS 1140b, a super-Earth located about 49 light-years away. This planet stands out due to its rocky composition and its position well within its star's habitable zone. What makes LHS 1140b even more intriguing is its dense atmosphere, which scientists believe may contain water vapor or other elements essential to life. Studies of its star, a red dwarf, also suggest a stable environment that could provide the longevity needed for life to develop. Beyond LHS 1140b, other fascinating discoveries include planets such as Kepler 186f and TOI 700d, which also lie within the Goldilocks zone and exhibit Earth-like characteristics. These findings not only expand our understanding of potentially habitable environments, but also challenge the belief that Earth is uniquely suited for life. Each new discovery reinforces the idea that life-supporting conditions might be more common in the universe than previously thought, further inspiring scientists to continue their search for these distant, yet tantalizingly familiar worlds. As we uncover more about these planets, we inch closer to answering one of humanity's most profound questions. Are we truly alone? Moving forward, let us introduce the fascinating concept of galactic habitable zones, which expands the idea of habitability beyond individual planets to entire regions within galaxies. Just as planets have a habitable zone around their stars, galaxies also feature regions where conditions are most conducive to supporting life. These zones are determined by a combination of factors, including the availability of essential elements for life, a stable environment shielded from harmful cosmic radiation, and proximity to stars capable of sustaining planetary systems. In the case of our Milky Way, scientists have identified a region often referred to as the galactic habitable zone, located approximately halfway between the galactic core and the outer edge of the galaxy's spiral arms. This area benefits from a delicate balance of elements like carbon, oxygen, and nitrogen, key components of organic molecules, and sufficient distance from the tumultuous activity near the galactic center, such as supernova explosions and intense radiation. Within this zone lies our very own solar system, shining as a prime example of how life may flourish under these favorable conditions. The implications of these discoveries are profound, as they guide researchers to focus their search for extraterrestrial life on planets orbiting stars within similar habitable regions in other galaxies. This concept also raises intriguing questions about the distribution of life across the universe, suggesting that civilizations may be more likely to emerge in these sweet spots scattered among billions of stars. By studying galactic habitable zones, we gain a broader perspective on the factors that enable life to exist, bringing us one step closer to uncovering our cosmic neighbors. Now turning to the intriguing phenomenon of fast radio bursts, these are extraordinarily brief yet powerful flashes of radio waves originating from distant galaxies. Their mysterious nature has captivated scientists since their initial discovery, as they defy easy explanation. Among the most fascinating examples is the repeating signal designated as FRB 121102, which has displayed an unusual and consistent pattern of repetition. This stands out because most fast radio bursts are typically one-time events, disappearing as quickly as they are detected. The repetition of FRB 121102 has sparked intense speculation about its source, leading some researchers to propose natural explanations such as highly magnetized neutron stars or the dynamics of black holes. However, others entertain the tantalizing idea that these signals might be technosignatures, potential evidence of advanced extraterrestrial civilizations attempting to communicate or harness energy in ways we have yet to understand. To explore these possibilities, scientists are employing cutting-edge radio telescopes like the ones used in the Breakthrough Listen project, a global initiative dedicated to scanning the skies for signs of intelligent life. By analyzing the frequency, energy, and timing of these bursts, researchers hope to determine whether their origins are entirely natural or something far more extraordinary. The search is ongoing, with more fast radio bursts being catalogued each year, pushing the boundaries of what we know about the universe and maintaining the hope that one day we may decode a signal that confirms we are not alone. With this remarkable challenge in mind, we move closer to exploring how unusual cosmic phenomena could intersect with the search for life. Moving forward, we dive into the fascinating discovery of distant planets known as water worlds, celestial bodies that are entirely or predominantly covered by global oceans. These exoplanets differ significantly from Earth-like planets with their vast, uninterrupted bodies of water that could be tens or even hundreds of miles deep. This unique feature has captured the attention of scientists, as water is one of the fundamental ingredients required for life as we know it. The expansive oceans of these water worlds provide an environment where life could potentially emerge or thrive, shielded from harsh cosmic radiation and extreme temperature fluctuations. Researchers speculate that certain water worlds might host hydrothermal vents on their ocean floors, much like those found in Earth's deep seas, where chemical-rich plumes could serve as energy sources for microbial life. In contrast to Earth-like planets, where liquid water is typically limited to surface bodies such as rivers, lakes, and oceans, water worlds offer a planet-wide aquatic environment, vastly expanding the potential habitable space. Scientists are particularly excited by recent discoveries of water worlds in the habitable zones of their stars, where temperatures could allow liquid water to exist. Instruments like the James Webb Space Telescope are providing unprecedented insights into the atmospheres and compositions of these exoplanets, searching for markers such as water vapor or other chemical signatures that could point to biological activity. Though the conditions on water worlds might seem alien and extreme compared to Earth, their potential to harbor life underscores the incredible diversity and adaptability of life that could exist across the universe. This ongoing exploration of water worlds continues to reshape our understanding of what it takes for life to thrive and provides yet another hopeful avenue in the search for extraterrestrial life. Now turning to one of the most intriguing mysteries of the cosmos, let us explore the interstellar object known as Oumuamua, first observed in 2017 as it passed through our solar system. Oumuamua immediately captivated scientists due to its highly unusual characteristics. Unlike any asteroid or comet ever seen, its elongated, cigar-like shape and tumbling motion defied conventional explanations. Adding to the mystery, it exhibited an unexpected acceleration, as if propelled by an unseen force, leading to speculation about its true nature. Some researchers propose natural explanations, such as a fragment of a shattered planet or a peculiar type of icy body that released gas in a way that created its strange trajectory. However, others have gone further, suggesting the possibility that Oumuamua might be an artificial object, perhaps a probe sent by an advanced extraterrestrial civilization. This controversial theory gained traction due to the object's lack of a visible cometary tail or substantial heat signature, characteristics that do not align with typical natural objects. The debate over Oumuamua highlights the challenges of interpreting limited data from a fleeting cosmic visitor, as it has already left our solar system, making follow-up observations impossible. Despite the uncertainty, Oumuamua has inspired new questions about the types of objects traveling through interstellar space and what they might reveal about the broader universe. Its brief but enigmatic appearance reminds us of how little we know about the phenomena beyond our solar system and motivates continued advancements in technology to better observe and understand these extraordinary arrivals. With mysteries like Oumuamua igniting curiosity, the search for answers could provide profound insights into the universe's secrets and our potential place within it. Moving forward, we encounter the perplexing case of Tabby's star, formerly known as KIC 8462852, a celestial object that has baffled astronomers since its peculiar behavior was first observed. Located approximately 1,480 light-years away in the constellation Cygnus, Tabby's star exhibits irregular and extreme dimming patterns unlike anything seen in other stars. These fluctuations have sparked a wide range of theories, with some proposing natural explanations and others venturing into the realm of the extraordinary. Among the natural possibilities are swarms of orbiting comets, vast clouds of interstellar dust, or even remnants from a planetary collision. However, none of these theories fully account for the unpredictable and significant drops in brightness, with some episodes reducing the star's luminosity by up to 22%. This level of dimming is far greater than what a planet passing in front of a star could cause, which is why the mystery remains unresolved. Intriguingly, some scientists have speculated that the dimming might be caused by massive structures built by an advanced extraterrestrial civilization, such as a Dyson sphere, a hypothetical megastructure designed to harness energy from a star. While this idea is purely speculative, it has captured public imagination and highlights how little we understand about unusual stellar phenomena. Research into Tabby's star continues, with astronomers using advanced telescopes to gather more data and explore potential explanations. Observations across various wavelengths of light aim to identify clues about the materials or processes causing the dimming. Despite years of study, Tabby's star remains one of the most enigmatic objects in the universe, reminding us of the vast unknowns that await discovery. This ongoing enigma fuels our drive to explore the cosmos, pushing the boundaries of both technology and imagination as we seek answers. Now turning to a fascinating discovery that brings the quest for extraterrestrial life even closer to home, we delve into the mystery of ancient meteorite fossils. One of the most compelling examples is the Allen Hills 84001 meteorite, a rock from Mars that was discovered in Antarctica in the year 1984. This meteorite gained worldwide attention in the year 1996 when scientists announced they had found what appeared to be fossilized microbial structures within it. These tiny, tube-like formations sparked intense debate, as their resemblance to certain microbial fossils found on Earth hinted at the possibility of ancient life on Mars. The formations were accompanied by other intriguing clues, such as the presence of complex organic molecules and mineral deposits that, on Earth, often form as a result of biological activity. While skeptics argue that these features could be the result of non-biological processes, the discovery has undeniably opened up new avenues of research into the potential for life beyond Earth. This meteorite isn't an isolated case either, as researchers continue to examine other space rocks for similar signs of ancient life. Each new finding deepens our understanding of how life might arise and survive in extraterrestrial environments. The Allen Hills meteorite serves as a powerful reminder that even small clues can lead to groundbreaking questions about our place in the universe, keeping the search for life beyond Earth as one of the most thrilling scientific pursuits of our time. Moving forward, let us revisit one of the most intriguing tools used in the search for extraterrestrial life, the Drake equation. Originally devised in the year 1961 by astronomer Frank Drake, this equation is a mathematical framework designed to estimate the number of advanced civilizations that might exist in our galaxy. It incorporates a series of factors such as the rate of star formation, the fraction of those stars with planets, and the likelihood of life developing and evolving into intelligent beings capable of communication. While the equation itself does not provide definitive answers, it serves as a thought-provoking guide in our quest to understand the potential for life beyond Earth. Recently, new data from advanced space missions and observatories has breathed fresh life into this equation. For instance, the discovery of thousands of exoplanets has provided more accurate estimates for the fraction of stars hosting planetary systems. Among these, a significant number are located in the so-called habitable zone, where conditions may support liquid water, a key ingredient for life as we know it. In addition, modern studies of planetary atmospheres, using tools like spectroscopy, are refining our understanding of which planets might possess environments suitable for life. Even the development of artificial intelligence is playing a role by helping to process vast amounts of cosmic data and identify potential signals from distant civilizations. As each new discovery adds pieces to the puzzle, the Drake equation evolves from a speculative exercise into a framework increasingly grounded in observable data. This shift underscores an exhilarating reality. We are no longer just guessing about the probability of other civilizations. We are actively collecting evidence that could one day confirm we are not alone in the cosmos. The Drake equation, enriched by modern science, continues to steer humanity's most profound exploration, reminding us that the answers we seek might be closer than we ever imagined. Now turning to the fascinating realm of exoplanet atmospheres, recent discoveries have unveiled chemical signatures that might hint at the presence of life. Using advanced spectrometry, scientists can now analyze the light passing through or reflecting off these distant atmospheres, breaking it down to identify the specific molecules present. Among the most intriguing findings are traces of oxygen, methane, and water vapor molecules that on Earth are closely tied to biological processes. Even more compelling are instances where these chemicals appear together in combinations that are difficult to explain through natural geological or chemical processes alone. For example, the simultaneous presence of methane and oxygen in an atmosphere could suggest active biological cycles, as these gases tend to destroy each other unless they are continuously replenished by some source. Tools like the James Webb Space Telescope are sharpening our ability to detect these subtle signatures, offering unprecedented sensitivity to faint signals from planets that orbit distant stars. What makes this even more remarkable is the ability to distinguish between planets with conditions resembling Earth's and those with entirely unique chemistries that could support forms of life beyond anything we have ever imagined. This leap in technology bridges the gap between speculation and science, empowering researchers to pinpoint worlds that may be emitting the chemical fingerprints of life. By shedding light on distant atmospheres and their mysteries, spectrometry has become a cornerstone in the search for life, encouraging us to look deeper and dream bigger as we unravel the secrets of the cosmos. Moving forward, this journey into the unknown invites even more groundbreaking discoveries, illuminating the path to understanding what might truly be out there. Moving forward, let us explore the groundbreaking potential of upcoming Starshade missions, a technological marvel designed to transform how we search for life beyond our solar system. Imagine a colossal, flower-shaped spacecraft positioned millions of miles away from an orbiting telescope, working in perfect synchrony. The purpose of the Starshade is as ingenious as it is profound. It blocks out the intense light of a star, creating a shadow that allows scientists to detect the much fainter light emitted or reflected by planets orbiting that star. Why is this so important? Stars are billions of times brighter than the planets around them, making it nearly impossible to directly observe these planets with traditional telescopes. By eliminating the overwhelming glare of the star, Starshade missions enable telescopes to focus on the faint, hidden worlds that have remained elusive until now. This could provide us with a direct glimpse of exoplanets, offering the chance to study their atmospheres, climates, and even potential surfaces in unparalleled detail. The implications are staggering. For the first time, we could visually confirm Earth-like worlds in the habitable zones of distant solar systems. Even more exciting is the prospect of detecting biosignatures, such as the combination of gases that indicate biological activity, with a degree of clarity never before achievable. Imagine capturing the light spectrum of an alien atmosphere and finding signs of water, oxygen, or other markers of life as we know it, or perhaps even as we do not know it. The starshade represents not just a leap in technology, but a fundamental shift in our ability to explore the universe. It bridges the gap between theory and observation, taking us closer to answering the profound question of whether we are alone in the cosmos. With these missions on the horizon, humanity stands at the edge of a new era in the search for life, one that could redefine our understanding of existence itself. Now turning to the Galileo project, this extraordinary initiative represents a bold step in humanity's quest to uncover evidence of alien technology. Founded with the mission to systematically explore unidentified aerial phenomena and search for artifacts of extraterrestrial origin, the Galileo project is guided by cutting-edge scientific rigor and an unwavering commitment to discovery. Imagine deploying advanced telescopes, sensors, and artificial intelligence systems to study mysterious phenomena in Earth's skies and beyond. The project seeks to go beyond anecdotes and blurry images, focusing instead on collecting hard data through meticulous observations and analysis. One of its key objectives is to identify and study any interstellar objects, similar to the enigmatic visitor Oumuamua, that might enter our solar system. Through the use of sophisticated instruments, researchers aim to determine whether such objects could bear hallmarks of non-natural origins, potentially redefining our understanding of what might constitute evidence of alien technology. Another pivotal goal of the Galileo project is to examine Earth's atmosphere for unexplained aerial phenomena using state-of-the-art detection systems. By applying artificial intelligence to analyze data streams, the project seeks to separate naturally occurring events from those that might hint at advanced technological origins. Recent advancements by the project include the development of specialized observatories equipped with high-resolution sensors specifically designed to track and record anomalous aerial events. These observatories provide a level of precision and reliability that ensures findings are grounded in verifiable evidence. The Galileo project is not only a scientific initiative, but also a testament to the power of curiosity and the human drive to explore the unknown. By pushing the boundaries of what we can observe and analyze, this endeavor bridges the gap between speculation and empirical evidence, bringing us closer to the possibility of confirming alien technology. As this ambitious project unfolds, it holds the potential to reshape our understanding of the universe and our place within it, offering tantalizing glimpses into a reality we are only beginning to comprehend. Moving forward, let us explore the intriguing possibility of life in the clouds of Jupiter. While the planet's surface is an uninhabitable expanse of crushing pressure and searing temperatures, its upper atmosphere presents a far more tantalizing prospect. At specific altitudes in Jupiter's thick cloud layers, conditions such as temperature, pressure, and the presence of certain chemicals create an environment where microbial life could theoretically exist. Researchers have long speculated that these cloud layers could act as a habitat for life forms similar to Earth's extremophiles, microorganisms that thrive in the most hostile environments. Jupiter's atmosphere is known to contain water vapor, ammonia, methane, and hydrogen, among other elements, which could serve as essential ingredients or energy sources for microbial life. Additionally, the planet's intense radiation and lightning activity might provide the energy needed to drive chemical reactions that sustain life. While these conditions are far from ordinary, they raise compelling questions about the adaptability of life and its potential to exist in environments vastly different from those on Earth. The possibility of life in Jupiter's clouds remains speculative, but it highlights the need for continued exploration. Future missions, such as robotic probes capable of sampling the atmosphere, could provide the data necessary to answer this cosmic mystery. By probing deeper into Jupiter's secrets, not only could we expand our understanding of potential habitats for life, but we might also redefine the boundaries of where life could exist in the universe. Now turning to the discovery of biogenic gases on distant planets, we find ourselves exploring one of the most promising leads in the search for extraterrestrial life. Scientists have identified key gases such as ammonia, methane, and nitrous oxide in the atmospheres of exoplanets, and these gases are often referred to as biomarkers. But what makes these chemical signatures so significant? On Earth, these gases are naturally produced through biological processes. For example, methane is generated by microbial life in wetlands and even in the digestive systems of animals. Similarly, nitrous oxide, commonly known as laughing gas, is released by certain types of bacteria during the breakdown of nitrogen compounds. The presence of these gases in an exoplanet's atmosphere could therefore suggest that similar biological processes are occurring there. Of course, detecting such gases does not guarantee the existence of life, as non-biological processes like volcanic activity can also produce them. However, when these biomarkers are found in specific combinations or occur alongside other indicators like water vapor or oxygen, the likelihood of biological origins becomes far more compelling. Advanced telescopes and spectrography tools are allowing us to study these distant worlds with unprecedented precision, analyzing the light that passes through their atmospheres to uncover their chemical makeup. In fact, some exoplanets located in the so-called habitable zones of their stars, regions where conditions might support liquid water, have already shown hints of these gases. These discoveries are not merely scientific milestones. They are glimpses into the potential diversity of life beyond Earth. As instruments like the James Webb Space Telescope continue to refine our capabilities, we may soon find ourselves unraveling whether these gases are the fingerprints of alien life or merely echoes of unique planetary chemistry. Either way, they guide us forward, reminding us how endless the possibilities are. Moving forward, we venture into the enigmatic realm of dark matter and its potential influence on life in the universe. Dark matter, an invisible form of matter that makes up about 85% of the universe's mass, does not emit, absorb, or reflect light, making it incredibly elusive. Yet, its gravitational effects are unmistakable, shaping galaxies and holding cosmic structures together. But could this mysterious substance also play a role in the conditions that foster life? Some speculative theories suggest that dark matter might indirectly impact the habitability of planets. For instance, its gravitational pull could influence the stability of planetary orbits within habitable zones, regions where conditions are just right for liquid water to exist. Stable orbits are crucial for maintaining consistent climates, which in turn are vital for the development and sustainability of life. Beyond gravitational effects, there are more audacious ideas. Some researchers hypothesize that the interaction between dark matter particles and ordinary matter could generate heat deep within planets. If true, this could provide a crucial energy source, particularly for subsurface environments, such as oceans beneath icy layers on moons like Europa or Enceladus, where sunlight cannot penetrate. There are even more unconventional speculations that link dark matter to unexplained phenomena, such as bursts of energy or anomalies observed in distant galaxies. Could these anomalies hint at interactions that might indirectly or even directly support life? While these ideas remain highly theoretical and lack concrete evidence, they open new avenues of thought about how life might arise or thrive under conditions we have yet to fully comprehend. As scientists continue to study dark matter through experiments and observations, new discoveries could illuminate its role in the cosmic puzzle. Whether it turns out to be a silent bystander or a hidden player in the theater of life, dark matter reminds us of the vast unknowns that still await exploration in our universe. Now turning to the groundbreaking discovery of gravitational waves, a phenomenon that ripples through the very fabric of space and time. These waves were first directly detected thanks to extraordinary advancements in observational technology, revolutionizing our grasp of cosmic events. Gravitational waves are created by some of the most dramatic occurrences in the universe, such as the collision of black holes or neutron stars. By studying these waves, scientists can peer into regions of the cosmos that were previously hidden, offering a new lens into the dynamic movements of the universe. But how might this enigmatic discovery intersect with the search for life? One intriguing possibility lies in the way gravitational waves could help pinpoint regions in the universe where conditions might be conducive to life. For example, these waves carry unique information about the behavior and distribution of celestial bodies, such as stars and planets. Analyzing this data could reveal areas where planetary systems are stable and capable of hosting habitable zones. Moreover, the events that generate gravitational waves often involve the release of heavy elements into space, elements that are essential for building planets and potentially the building blocks of life. This cosmic recycling of materials could play a crucial role in creating environments where life might one day emerge. Beyond this, the precise mapping of gravitational wave sources has the potential to uncover hidden planetary systems that traditional telescopes may have overlooked. These systems, if within the habitable zone of their host stars, could become prime targets for further exploration. While the study of gravitational waves is still in its infancy, each new observation brings us closer to unraveling how the violent and beautiful dynamics of the universe might create the perfect conditions for life to thrive. As we continue to listen to the whispers of the cosmos through these ripples in space-time, we edge closer to uncovering the profound connections between the universe's grandest events and the possibility of life beyond our own. Now turning to the discovery of Earth-like planets in binary star systems, a finding that has redefined what we consider potential cradles for life. For decades, binary star systems where two stars orbit around each other were thought to be too unstable for planets to host life. The gravitational tug-of-war between the two stars was believed to create chaotic orbits, making it nearly impossible for planets to maintain the steady conditions necessary for life to thrive. However, recent discoveries have turned this assumption on its head. Scientists have now identified Earth-sized planets in the habitable zones of these binary systems, where conditions could allow liquid water to exist. These planets, often referred to as Earth's twins, are showing surprising stability in their orbits, defying earlier predictions. What makes this discovery even more exciting is that binary star systems are incredibly common in our galaxy, potentially doubling the number of places where life could emerge. Imagine a planet orbiting one star while its skies are illuminated by a second sun, a breathtaking environment that could host its own unique ecosystems. The discovery of planets in these systems expands our understanding of where life might thrive, challenging the traditional notion that single-star systems like our own are the prime candidates for habitability. With new technologies and missions, such as advanced space telescopes equipped with cutting-edge imaging capabilities, scientists are now able to study these binary systems in much greater detail than ever before. These efforts are uncovering planetary environments that may be suitable not only for microbial life but possibly even more complex organisms. The implications of this are enormous as it broadens the scope of our search for life, opening up entirely new frontiers. As we delve deeper into these twin star systems, we may find that the conditions for life are far more diverse and widespread than we ever imagined, bringing us closer to answering the ultimate question: are we truly alone? Moving forward, let us delve into one of the most fascinating theoretical possibilities in the search for extraterrestrial life: fossilized stromatolites on alien worlds. Stromatolites found on Earth are layered structures formed by microorganisms, often in shallow water environments. They represent some of the earliest evidence of life on our planet, dating back over 3.5 billion years. These ancient formations are created as microbial communities capture and bind sedimentary grains or precipitate minerals, leaving behind a signature of their biological activity. Now, imagine similar formations existing on other planets or moons, preserving ancient traces of life. Theoretically, stromatolites could form anywhere conditions are favorable for microbial life, such as bodies of water with abundant minerals and energy sources. Planets or moons with histories of liquid water and the right chemical ingredients like Mars, Europa, or Enceladus are potential candidates for hosting fossilized stromatolites. The discovery of such structures on alien worlds would be monumental, as it would signify not just the presence of life but also its persistence over vast timescales. Furthermore, stromatolites are remarkably resilient, able to endure in the geological record for billions of years, making them ideal targets for planetary exploration missions. For example, the exploration of Mars has already hinted at the possibility of ancient microbial life through the identification of features in sedimentary rocks that resemble stromatolites. Instruments like rovers and orbiters, equipped with advanced imaging and spectroscopy tools, are crucial in identifying these formations and analyzing their composition to determine whether they are of biological origin. Beyond Mars, scientists are also intrigued by the potential for stromatolite-like structures on icy moons. Europa's subsurface ocean, locked beneath an icy crust, could harbor microbial life that leaves behind similar formations, especially if hydrothermal vents are present on the ocean floor. By studying stromatolites on Earth, researchers are creating models to guide the search for these potential fossils on other worlds. If detected, such formations would provide a window into the biological history of an alien world, offering indisputable evidence that life is not unique to Earth. This possibility underscores the importance of continued exploration and the development of technologies capable of unearthing these clues, as finding fossilized stromatolites on alien worlds could reshape our understanding of life's universality and its capacity to endure through time. As the next phase of the journey unfolds, let us explore how artificial intelligence is revolutionizing the search for extraterrestrial life and the study of the cosmos. Artificial intelligence, with its unparalleled ability to process and analyze vast amounts of data at lightning speed, is becoming an indispensable tool in space exploration. Modern telescopes and observatories generate staggering amounts of data, from spectral analysis of exoplanet atmospheres to the detection of faint signals across the cosmos. Manually analyzing this information would take countless years, but artificial intelligence can sort, classify, and identify patterns within moments, allowing scientists to focus on the most promising leads. For instance, artificial intelligence algorithms are being used to spot anomalies in exoplanetary data, such as unusual chemical signatures or atmospheric compositions that might hint at biological activity. These same tools are also helping to map and model planetary surfaces in unprecedented detail, enabling researchers to identify potential landing sites for future missions or regions of interest that warrant further study. Beyond detection, artificial intelligence is also assisting in simulating conditions on alien worlds. By processing data from Earth analogs and lab experiments, it can predict how life might arise and adapt in environments vastly different from our own. Moreover, artificial intelligence has been instrumental in the search for technosignatures, indicators of advanced civilizations. Algorithms designed to detect non-natural patterns in radio signals or light spectra are helping scientists comb through the immense datasets collected by initiatives like the Breakthrough Listen project. These advancements not only accelerate the pace of discovery but also increase the precision of our search efforts. With artificial intelligence constantly improving, the potential for breakthroughs in astrobiology and cosmology is greater than ever. As we continue to refine these technologies, we edge closer to answering one of humanity's most profound questions. Are we alone in the universe? This extraordinary intersection of human ingenuity and machine intelligence underscores the importance of investing in cutting-edge research, as the tools of today may ultimately reveal the secrets of tomorrow. As we reflect on the incredible discoveries discussed throughout this journey, one thing becomes increasingly clear. We are closer than ever to answering the age-old question, are we alone in the universe? From the detection of microbial signatures in ancient Mars rocks to the presence of vast subsurface oceans on distant moons, and even the potential signs of life in exoplanet atmospheres, each breakthrough brings us one step closer to unraveling the mysteries of cosmic life. We stand at the edge of a new era where advancements in technology, driven by both human curiosity and artificial intelligence, are accelerating our understanding of the cosmos at an unprecedented pace. These discoveries remind us of the vast potential that lies beyond our planet and the importance of continuing our exploration of the universe. The search for extraterrestrial life is not merely a scientific endeavor. It is a quest to understand our place in the cosmos and the conditions that make life possible. As we peer deeper into the unknown, we are reminded of the infinite possibilities that await us. So, what do you think? Could the answers be just around the corner, waiting for us to uncover? If you enjoyed this exploration into cosmic mysteries, make sure to like this video, subscribe to our channel, and hit the notification bell so you never miss out on our next cosmic adventure. Let us know your thoughts in the comments below. What discovery do you find most fascinating, and where do you think life could exist beyond Earth? Together, let us continue to chase the stars and uncover the secrets of our universe.